Okay. So, in the previous lecture we finished it here that your that case 2, right, those data everything were given. This is the disco participation matrix DPM, and based on that your scheduled tie power flow was calculated and it was minus 0.02 per unit megawatt. So, actual also will be minus 0.02 per unit megawatt at the steady state, right. Now, figure 6 shows the dynamic responses. So, figures I will come later, right, I will come to that, but as given by equation 8 you can contact that steady state your power generated by each GENCOs, that is delta Pg1 steady state is nothing but delta P1. So, you can easily calculate Cpf11 into delta PL1 plus Cpf12 into delta PL2 plus Cpf13 into delta PL3. So, Cpf13 was 0 here, right. So, Cpf13 was 0 and Cpf14 into delta PL4, but delta PL1, delta PL2, delta PL3 and delta PL4 all are same 0.040404. So, delta Pg1 steady state will be 0.042 per unit megawatt, right. Now, similarly, delta Pg2 steady state is equal to delta P2, and now you know everything, delta P2 is equal to Cpf21 delta PL1 plus Cpf your 22 delta PL2 plus Cpf23 plus delta PL3 plus Cpf24 delta PL4. If you compute, it will become 0.018 per unit megawatt. Similarly, for delta Pg3 steady state, if you do in similar way, it will be 0.078 per unit megawatt. Similarly, delta Pg4 steady state will be 0.022 per unit megawatt, right. Now, this is steady state, but when we will see that your simulate your responses, right. So, this is figure 5 and but this is your now for the case 2 it is figure 6. So, frequency deviation at steady state it is going to 0 in area 1, similarly in area 2 also it is going to 0, right, and delta P or P tie actual when it is actually showing minus 0.02. look that delta P tie 1 2, that your schedule value we computed, that is delta P tie 1 2, that schedule value was minus 0.02 per unit megawatt, and you are getting minus 0.02 per unit megawatt, right, and basically and that is your nothing but that actual, right, and this one actually delta P tie 1 to actual, because at the steady state delta P tie 1 to error will be 0. So, delta P tie 1 to actual will be delta P tie 1 to schedule power, that is actually minus 0.02. So, just to give you a feeling of the dynamic simulation. So, this is the result, right. So, similarly, when if you go to the generation, right. So, this is delta P tie 1 to error, delta P tie 1 to error at steady state will be 0, because this is 0 line. So, it is actually 0, right. Now, delta Pg1 the generation if you see delta Pg1 per unit megawatt it is 0.042 at steady state. So, it is coming, right. Similarly, delta Pg2 per unit megawatt it is 0, it was this is 0.042 per unit megawatt, right. Similarly, delta Pg2 it is 0.018 per unit megawatt, right, and similarly delta Pg3 at steady state your 0.078 per unit megawatt. So, next I will come to your delta Pg4 next page. So, all the things are matching at the steady state. During your transient imbalance or during transient some oscillations will be there, finally, it will come to the your steady state values, right. So, and delta Pg4, right, and this is my delta Pg4. So, this is also your this one also at steady state it is 0. I think 022 per unit megawatt, right. So, this is also matching in the steady state. So, and some transient when transient will disappear finally reaches to a steady state, but for this simulation for this thing no GRC was considered, right. that we will see later, but no GRC was considered. So, next is case 3 is actually we call it as contract violation, right. Contract violation means suppose distribution companies, they have some contract with different generation companies, but and based on that the contract participation factor the DPM was formed. But when contract violation means suppose a distribution company is total contracted power demand is say 0.05 per unit megawatt, but all of a sudden it needs extra 0.02 per unit megawatt. So, which was not in contract. So, how to incorporate that uncontracted power demand in the model and simulation, that we will see here. So, it may happen that a DISCO violates a contract by demanding more power than that specified in the contract, right. This excess power is not contracted out of any GENCO, right. This uncontracted power must be supplied by the GENCOs in the same area as the DISCOs, right. That means, suppose in area 1 you have two distribution companies, say DISCO 1 and DISCO 2, and two generation companies GENCO 1 and GENCO 2. Suppose all of a sudden DISCO 1 demands some additional power which was not in contract, and it is expected that power demand of the DISCO will be met by the your GENCO in area 1, right. So, that was the idea. So, it must be reflected as a local load of the area, but not as the contract demand. That is why in that block diagram in area 1 and area 2 it was shown delta PL1 UC, that is delta PL1 uncontracted demand, and in area 2 also delta PL2 UC, the delta PL2 uncontracted demand. Now, consider case 2 again with a modification that DISCO 1 demands 0.04 per unit megawatt of excess power. I mean it has a contract power of 0.04 per unit megawatt, it has already 0.04 per unit megawatt. In addition to that, it also wants 0.04, that means total now 0.08, but this 0.04 was contracted power, but other 0.04 that it has your what you call that in area 1 two generation companies are there, GENCO 1 and GENCO 2, and accordingly that this power will be supplied by that same GENCOs in the area 1. But how this my question is now that how this that additional 0.04 per unit megawatt power, how it will be decided by the your what you call by two GENCOs. It depends actually on the AC participation factor. For example, suppose if you choose in area 1 AC participation factor for GENCO 1, say it is 0.70, right, and A dash 1 2 suppose it is 0.30, total has to be 1. So, that means if you set this AC participation factor for example, then that GENCO 1 will generate 0.04 into your 0.70, right, and this is 0.30. So, GENCO 1 will generate this one into 0.7, so 0.028 per unit megawatt, right. Similarly, that GENCO 2 in area 1, because we have set the participation factor A dash 1 to 0.3, so it will be 0.04 into 0.3, so that is 0.012 per unit megawatt, right. So, total is 0.04. Now, suppose if I take A dash 11 is equal to 1.0 and A dash 12 is equal to 0.0, then in that case the GENCO 2 will not generate share any uncontracted power demand, but GENCO 1 as it is 1, so it will be 1 into 0.04. So, GENCO 1 will generate that 0.04 per unit megawatt power, right. So, this is the idea that in that case suppose DISCO 1 demands 0.04 per unit megawatt power excess of power, that is delta PUC 1, that is in area 1 uncontracted power is 0.04 and delta PUC 2 is 0.0 per unit megawatt, because in area 2 no DISCOs demand any excess power, right. So, therefore, now total load in area 1, load of DISCO 1 plus load of DISCO 2, that means that your total load will be that already delta PL1 is the total load of the DISCO 1, then delta PL2 is total load of DISCO 2 plus this additional your what you call delta PUC1 coming, which has been demanded by the DISCO 1, the distribution company 1. So, total will be 0.12 per unit megawatt, that is the total disturbance in area 1, right. Similarly, total load in area 2 will be 0.08, because that your here no DISCO your what you call has any excess power demand. So, delta PL3 0.04, delta PL4 0.04. So, total is 0.08 per unit megawatt, right. Now, simulation result I will come later, that figure 7 shows the dynamic responses under this condition, right. So, the question is that your what you call if we go back to your that AC participation factor, just let me recall how much we took. If we, here what we did, that look, we took AC participation factor for GENCO 1 0.75 and for GENCO 2 0.25, right. Area 2 there was no excess demand, that means that GENCO 1 will share 0.75, right, additional thing into your 0.04, right. So, that is nothing but 0.03 per unit megawatt, right. Similarly, that your GENCO 2, that is 0.25, so it will be 0.25 into 0.04, so that is 0.01 per unit megawatt. So, apart from generating your contracted power, that is in case 2, right. So, whatever delta PG1 steady state was there, according to the apart from that, this 0.03 will be added to GENCO 1 power and 0.01 will be added to GENCO 1 power, that they have to generate at the steady state. So, if we go by, if you now move to the problem. So, here that this is called contract violation, right. So, if you look at that, all data remains as in case 2, right. That means, I am coming to the case 2. So, for the case 3, that uncontracted power demand. So, delta PG1 steady state, in the case of uncontracted power demand, that GENCO is generating another additional 0.03 per unit megawatt. That means, GENCO as steady state will generate this one plus 0.03, because APF is given, that AC participation factor, that is A-11 is given 0.75. So, 0.75 into 0.04, that is the uncontracted power demand. So, basically it will become 0.072 per unit megawatt, that is supposed to generate at steady state. Similarly, delta PG2, it was 0.018, but in addition to that, its AC participation factor is 0.25. So, 0.25 into 0.04, so 0.101 that I showed you. So, that means this one will generate at steady state plus 0.01. So, 0.028 per unit megawatt, but delta PG3 and PG4 will remain same, because there was no uncontracted power demand in your in area 2, right, sorry, by the DISCOs in area 2. So, that means, so figure shows the dynamic responses, right. So, I will go to that dynamic responses. So, if I go back to your figure 7, right. So, this is figure 7a. So, if you look into that figure 7, the frequency deviation in area 1 as steady state, it is 0, right. This is frequency deviation in area 1. This is for your this response is for your case 3, that is your contract violation. Below all the responses are for contract violation, right. So, this is your delta F1. Now, we will go to the next response, that delta F2 and others, right. So, now delta F2, that frequency deviation at steady state, it is also 0, and delta p tie 1 to actual will remain as it is, that is a steady state 0.02, because your only uncontracted demand is there and AGC that controllers are also there. Now, delta p tie 1 to error also will be a steady state, it is 0, right. But as I told you that your it was for the case 2 it was 0.04, right. plus AC participation factor for GENCO in area 1 was 0.75. So, plus 0.03 will be added, because 0.04 into 0.75. So, total will be your 0.07, it was what you call 42 plus 03. So, 0.072, right. So, that means if you look into this your dynamic responses, that your delta Pg1, it is actually your 0.072, right. So, similarly for your delta Pg2, it will be 0.028. So, if you look into that, this dynamic responses, that this one for delta Pg2. So, for the case 2, it was 0.018 plus that AC participation factor for area for GENCO 2 0.25. So, 0.04 excess demand into 0.25, that is 0.01, right, that I told you, that is actually 0.028 per unit megawatt. So, that is why it is 0.02 per unit megawatt, but delta Pg3 and delta Pg4, it will remain unchanged as steady state. So, this is 0.078, right, and this is actually 0.018. So, this is actually the responses, right. So, that means this one is 0.028. So, that means for contract violation, that if it happens so, then it is expected that the generators of that company of that area will be able to give extra power to the DISCOs in that same area, right. So, just hold on, right, just hold on. So, all these things, if you look into this, that I explain everything, that therefore, this your it is seen that frequency deviation vanish in the steady state, as DISCO participation matrix is same as in the case 2, right, and the excess load demand is taken up by GENCOs in the same area. The tie line power is the same in case 2 in the steady state. In the steady state, the generation of GENCO 3 and GENCO 4 are not affected by the excess load of DISCO 1, I told you. And I told you also that delta Pg steady state will be 0.078, right, this thing, and delta Pg4 steady state will be 0.022, same as before, right. But delta Pg1, I told you it will be 0.0, because it is whatever it was, contracted demand was, I told you already, that was delta P1, and simulation also I showed you, right, plus A-11 into delta PUC1. So, that is 0.072 per unit megawatt, right. Similarly, your delta Pg2 steady state also, it was 0.012 plus your that 0.25, that AC participation factor of area your GENCO 2 in area 1 into that uncontracted power demand. So, it is 0.028 per unit megawatt. This is also shown in figure 7, right. So, I have showed you all these things, right. So, this is your one thing, and this exercise 2 problems are there. Before coming to exercise, I will come to one problem. Now, suppose you have 3 area system. This is called longitudinal system. That means no loop. Actually, this is area 1, this is area 2, and this is area 3. And just for the sake of our analysis, we have taken, just hold on. So, just hold on. So, we have taken your what you call that your 3 areas. So, area one you have 2 GENCOs and 2 DISCOs. So, to accommodate space. So, D1, D2 is actually DISCO 1 and DISCO 2, DISCO distribution comparison, I have made it short, and GENCOs I have made G1 and G2. So, DISCO means D, GENCO means G, right. So, and this is 1, 2, 3, and here also power flow is there, say 2 to 3, right. So, in this case that your delta p tie 1 2, right, and your this is delta p tie 2 3. So, first is how to form the your disco participation matrix. First you will look that it is a longitudinal system, 1 is connected to 2, 2 is connected to 3, but 1 is actually not connected to 3. That means discos here in area 1, they cannot have any contact with GENCOs in area 2, because there is no line in between that area 2 is coming, right. Similarly, the discos in area 3, that is D5 and D6, right, they cannot have any contact with GENCOs in area 1, that is G1 and G2, right. But discos in area 2, that is D3 D4, they can contact with GENCOs in area 1, that is G1 G2, or GENCOs in area 3, that is G5 G6, because this side also is connected, this side also is connected by the tie line, right. Now, if you try to find out the your contact participation factor in general, some of the elements CP32 or CP43, it may be 0, it depends on the which discos have contact with which GENCOs, but in general when you will make this your what you call that DPM, disco participation matrix. Now, consider D1, right. So, D1, this is D1, so distribution company 1, it may have contact with GENCO 1, so CPF 11, CPF 12, right. So, CPF 11, right, and disco this D1, right, also can have contact with your what you call that your GENCOs in the same area G2, so CPF 21, right. Similarly, this distribution company, they have contact with GENCO 3, that is why CPF 31 is there. Similarly, this one will have may have contact with G4, that is GENCO 4, that is why CPF 41. But these distribution companies cannot have any contact with G5 or G6, right, because there is no line, there is no line here, there is no line here, right. So, it is blank, not connected. So, that means your this part is 0, this part is 0, right. Now, similarly, if you take about D2, similar way, CPF 12, CPF 22 will be there, because it has contact with G1, G2, it can have contact with G3, G4. So, CPF 32, because this is G1, G2, G3, G4, G5, 6 GENCOs, right, and these are all discos, right. And but this distribution companies D2 cannot have any contact with G5 or G6, that is why this is 0, this is 0, right. Similarly, if you take distribution companies of D3, D4, D3 and D4, first you take D3. So, D3 distribution company can have contact with G1, G2 of area 1, or can have contact with G5 or G6 in area 3. Therefore, this matrix CPF 13, CPF 23, CPF 33, CPF 43, CPF 53 and CPF 63, all are there. Similarly, for D4 also can have contact with G3, G4 or G1, G2 or G5, G6, because already this side and this side interconnected by tie line, right. So, that is why CPF 14, CPF 24, 34, CPF 44, CPF 54, CPF 64. So, contact participation factor. Similarly, if you take D5, D5 cannot have contact with any G1 or G2, because it is not connected, it is Therefore, that your CPF your 15 is 0 and CPF 25 is also 0, but this distribution called D5 may have contact with G3, G4 or and G5, G6. That is why CPF 35, CPF 45, CPF 55 and CPF 65. Similarly, D6 cannot have any contact with G1 and G2. That is why 0, 0. Rest is CPF 36, CPF 46, CPF 56 and CPF 66, right. So, this is your how to form that your for longitudinal system, that your what you call that your disco participation matrix. This is actually DPM, this is actually DPM, right. Now, so similar way the delta p tie 1 2, that is your scheduled tie line power flow, you can easily compute, because here 2 all are there. Similarly, delta p tie 2 3 also you can easily compute, right. The way I have told you, same philosophy, you can easily compute your what you call delta p tie 1 2 schedule value and delta p tie 2 3 schedule value, right. Now, if Now, if it is connected, suppose if 1 to 2, 2 to 3, 1 to 2, 2 to 3, 3 to 1. Now, if it is connected, if it is a loop system now, if it is a loop system now, if it is connected, so 1 to, that means every distribution companies in any area, they have the access to contact power with all the GENCOs in other areas. For example, now the D1, D2, the DISCO 1, DISCO 2 now can contact also with GENCO 5, GENCO 6, right. So, apart from your GENCO 3 and GENCO 4, and G1, G2 already there, those generators are there in their own area. That means, at that time this matrix will not be, need not be 0, at that time it will be full matrix CPF 5 1, CPF your 5 2 and CPF 6 1, CPF 6 2. Similarly, here also it will be your CPF 1 5, CPF 1 6, CPF 2 5 and CPF 2 6, right. But after that a distribution companies may not have contact with all the generation companies. So, some of the elements may become 0, right. And final anyway sum of all the column elements should be 1. Here also all the column elements should be 1. So, all column elements if you add, all should be your unity, right. And your and another thing is that contacted power demand. So, in this case what will happen, that contacted power demand for this one, say delta PL1, that will be this is your delta PL1, that power demanded by distribution company 1, this is delta PL2, this is delta PL3, this is delta PL4, this is delta PL5 and this is delta PL6, right. Therefore, delta P1 will be CPF 11 delta PL1, CPF 12 delta PL2, CPF 13 delta PL3 plus CPF 14 delta PL4, other two terms 0 0, so it is 0, right. So, similarly for G2 delta P2 you can calculate, similarly for G3 you can calculate, similarly for G4 you can calculate the contacted power demand, similarly for G5 and G6, and all the in general all the contacted power demand is equal to that this one steady state value, that means whatever contacted power demand for each GENCOs, that is actually a steady state value, that is the power generated by the GENCOs at steady state, right. So, this is actually your what you call that this just if it is a longitudinal thing, right. So, little bit you will practice. So, there is here I have given a problem. So, right. So, consider a 3-phase your 3-phase power system, one is radial interconnected, that is I told you the longitudinal, another is loop interconnected, both I told you, right. Area 1 has 2 GENCOs and 2 DISCOs, area 2 has 3 GENCOs and 2 DISCOs, and area 3 has 2 GENCOs and 3 DISCOs, right. So, you please what you call in this case draw the block diagram for both the cases, that is a bigger one, and construct DPM. In this case you will construct the DISCO participation matrix, right. Also obtain the expression of scheduled tie line power flows. That means, you will find out delta P tie 1 to scheduled, delta P tie 2 3 scheduled, and 1 2 2 3, then delta P tie 1 3 scheduled when it is loop, right. When it is radial, delta P tie 1 2 and delta P tie 2 3. When it is a loop, you find out also delta P tie 1 3 scheduled, the expression, only the expression, right. And another example, this one if time permits I will solve you for just see that, let me see that. Another thing is the load following, after that this type of one problem I will solve it. Now, consider a 2 area interconnected power system. Area 1 consists of 2 GENCOs and 2 DISCOs, area 2 also consists of 2 GENCOs and 2 DISCOs, right, distribution companies. Contact participation factor as CPF 11 is given 0.4, CPF 21 0.3, CPF 31 0.1, CPF 41 0.2, and CPF 12 is equal to CPF 22 is equal to CPF 32 is equal to CPF 42 is equal to 0.25. Now, CPF 13 is equal to CPF 23 is 0.04. CPF 33 is equal to CPF 43 is 0.5, CPF 14 is equal to 0.3, CPF 24 0.0 and CPF 34 is equal to 0.7, CPF44 is 0, right. Assume that each DISCO demand 0.10 per unit megawatt power from GENCOs as defined by contract participation factors, and each GENCO participate in AGC as defined by the following ACE participation factor, that is A-11 is 0.75, A-12 0.25 and A-21 is equal to A-22 is equal to 0.5, right. You determine the output of each GENCO in the steady state. You only find out the steady state, because classroom we cannot ask you simulation, only steady state, right. Also, did you determine the scheduled power flow on the tie line and its direction? I mean, it is in the direction of 1 2 or 2 1, right. If DISCO 1 in area 1 and DISCO 4 in area 2 demands 0.10 per unit megawatt each of excess power, that is uncontracted power demand, right. That is your delta PUC 1 will be your 0.1 as well as delta PUC 4 will be 0.1 also, right. Calculate the output of each GENCO in the steady state, right. So, note that your what you call that GENCO 1, GENCO 2, DISCO 1 and DISCO 2 are in area 1 and GENCO 3, GENCO 4 and DISCO 3, DISCO 4 are in area 2, right. So, this problem you will try to solve of your own. Thank you very much. We will be back again.